Relative and absolute dating. These notes actually go along with the last ECQs that we wrote down, so there are no new ECQs. You're just going to set up the next page, Cornell style. Again, the title is Relative and Absolute Dating. Make sure you leave room at the top for your essential question, vocab and summary at the bottom. You do want to create a key for your highlighters somewhere, usually at the top in the upper right-hand corner by your page number is a good idea. One color for vocab and one color for facts, please. And the essential question for these notes are compare and contrast relative dating and absolute dating. So we're going to focus on these two different types of dating, which is, and dating, we're not talking about boy and girl dating, that type of thing. Dating is determining an age or how old something is. So that's what we're talking about. Okay, so we're going to start with relative dating, and this is determining whether an object is older or younger than another. And it's very simple. It's not, there's no numbers. It does not give an actual age. So when we're talking about you versus me, I'm older than you. That's relative dating right there. Just saying who's older and who's younger, or what's older, what's younger, and that's it. We don't have to say the age difference. We don't have to say how old I am versus how old you are, but it's just basically putting things in order, like it says here, from oldest to youngest. So if you look at these rock layers, we're saying that this bottom layer is the oldest, layers then stacked on top of it, and then this is an older one, and the youngest is this. This is like magma coming up through the center. So it would have to, all these other layers would have to be here first before this could come through. So this is a great example of relative dating, just saying oldest to youngest. Okay, and so when we are talking about doing dating, a lot of times we use sedimentary rock, and this is rock that forms from the fragments of other types of rock. And again, it's the most useful of rocks for relative datings because what happens is sediment is deposited and then it's lithified or hardens. So you can see here that these are all different layers of sediment rock that has basically just laid down and it's hardened, and then another layer lays down on top and it hardens again. And so it's really easy to see in this picture here that these layers down here are going to be older than these ones on the top. Okay, so the bottom, and we're going to get to that in the next slide. But basically we have layers of rock, which is sedimentary rock. And you can see here are some pictures of sedimentary rock as well, where it's a bunch of different things that just kind of come together and then harden as well. Okay. So superposition, it states that younger rocks lie above older rocks. And so it's a lot like that first picture we were looking at where the oldest is on the bottom and the youngest is on top. And there's lots of good ways to think about this. Think about your laundry basket. When you throw Monday's laundry in, and then you throw Tuesdays, Wednesdays, Thursday, Friday, Saturday, Sunday, and then mom does laundry, well, the bottom is the oldest because you've just piled layers up above. Okay, and so the oldest is on the bottom, the newest is on top. So if you're looking for something from Monday, you know you got to dig all the way to the bottom because it was the last thing. If you're looking for something from Saturday, it's going to be on the top because it was one of the last things that you threw in there. Okay, so superposition helps determine relative ages of rocks and fossils. So we can just, like, if this was our layer of sedimentary rock, we would know that A would be older than B, which would be older than C, then D, E, and F. And F would be our youngest layer because it's the last thing that was laid down. So it's the youngest. Okay. Last thing is absolute dating. Now, absolute dating is the opposite of relative dating. So here we're actually going to determine the age of an event in years. So determining the age of an event or object in years, that's absolute dating. And we use radioactive decay and the half-life of certain elements to determine how old things are, especially rock layers. So we can take samples of the rock and then look at different elements like carbon, it's over here is good, carbon, or if there's uranium, and you can see how old they are based on how much of the rock has decayed, okay? And so half-life is the time it takes for half of a sample to decay. And it shows you here the half-life of different things. And we can see the percentage of parent-daughter material in there will tell us how old something is. So here is an example of now using this information to determine the ages of these events. So this lava flow here was 180 million years old. This shale is 110 to 180 million years. And then again, another lava flow is about 110 million years ago. So that's what it's saying. So now we're not just saying that this is older than this, which is older than this. We're now saying this is 180 million years old, and this layer here is, 110 to 180, and then this is 110 million years old. Okay, so again, a good example is this here. And you may want to include this in your notes, it's up to you. You don't have to, but it is a great picture to show you the difference between relative and numerical. We're talking about absolute dating here. So the oldest layer is on the bottom, youngest layer is on the top. And with absolute dating, we're now telling how old different layers are. Okay, so this is the end of your notes. So go ahead and go back through, make sure you highlighted, and then create your 4 questions in the left column and write your 3-sentence summary. So you want to tell me the differences between relative dating and absolute dating. And that's it.